customers, right? Go here, we'll call it as customers table. You'll have an ID, you'll have a name, you'll have an address, and other columns. Okay, what is this one? This is the schema. You have the column names, data types, the children, parent relationship, and things like that. If you know the schema of your table, that is called structured data. Okay, but back on the internet today, internet and application logs are becoming your new source of data, guys. Okay, what is happening? The data is unstructured. You have data, but you do not know the column name. You do not even know if they have columns, they have data types, or if they have a parent, child, or anything. That is called unstructured data, guys. What is happening? If there is 10% of water in the world, there is 90% of water on in seas and oceans. Okay? If there is 10% of data in the database, there is 90% of the data available in the form of logs and internet, guys. Okay? That is what we are saying. Okay? The problem, storing is a problem, number one, that amount of data, because costs will be very, very high. Number two, analyzing and extracting insights is another problem. Why? The complexity of the code is really, really very high, guys. You have to be a mechanical engineer to drive a car. It's like saying that, okay? In other words, if you look in reality, all the drivers are not mechanical engineers. So we cannot expect a driver to be a mechanical engineer, guys, okay? So that is what I'm trying to convey here. The challenges of the unstructured data or the big data. The big data is a combination of both of them. What is happening? It is becoming increasingly complex to analyze and extract meaningful information, gentlemen. Okay. So shall I move on to the next slide, guys? Great. Okay. So traditionally, what companies were doing when they have big data is they would buy, when they have large amounts of data, guys, they will go ahead and buy a powerful server. A powerful server is an expensive server. It's called an enterprise class server, guys. Okay. What will they do? They will try to put all the big data into this single server. What will happen? There will always be a limit. Maybe you can put 1 terabyte, 10 terabyte, 20 terabytes, or 30 terabytes, or maybe 100 terabytes into a single server. But what if you get 100 terabytes of data? What will you do? Well, that will not be enough. What do? You go ahead and buy another server. What will happen? The costs will be increasing in exponential figures. That is a problem that they are having. Problem number one, costs will be growing, and then the amount of data that you can process on a single server will also have a limit, guys. You cannot go ahead and process infinite amounts of data, guys. That is a second problem they will have. Okay, so challenges of big data. Come here. To recap, storing the big data is a problem. Storing it in right time is another problem. Once you store it, or if you're able to store it with high cost, processing that data as big data is another problem. Or in other words, processing and analyzing to get the insights at right time, at right people, to the right people is another problem. In other words, the complexity of the code increases as these increase, and that's one of the biggest problems, guys. Okay, they cannot scale. Okay, in the world of Hadoop, guys, what happens is, let's say you have a single server, and let's say you're processing some data in this server. Okay, and let us say to process this data, it is taking 10 hours. Okay, now if I want that to be processed in 1 hour, gentlemen, we can go ahead and use 10 servers. Okay, we can split the data into 10 servers, and then now if I were to go ahead and put the data there, and I will split it into 10 parts. The same data, I will split it into 10 parts, and now I will do a computation. I will do the same computation on all of this data on the 10 servers, guys. Okay, it's almost a guarantee your time will reduce to 1 hour. Okay, and as your number of servers increase, right, your code complexity will not increase, guys. Okay, it will remain the same. So in other words, you will not make any code changes. Okay, so that is what is meant by linearly scalable. In traditional architectures, they are not linearly scalable. In Hadoop, they are linearly scalable, guys. Okay, and their traditional architectures, they are not very reliable. In other words, the reliability is not inbuilt into it. Okay, if it goes down, you will need to write a lot of exception handling and workarounds to secure your data. And another important thing, guys, traditional architectures, you use what is called enterprise class servers. They're very expensive. Okay, in the world of Hadoop, you will use something called commodity hardware. Those are very inexpensive, guys. So in other words, the traditional enterprise class server will range anywhere from $20,000 to $100,000, whereas an inexpensive commodity hardware will range in the orders of $5,000 to start with. Yes, okay. So even if you increase the number of servers, your cost will not be very high. They will not grow in an exponential rate. Whereas in traditional architectures, if I just add one more server, let's say I go ahead and add another server, my core cost will start growing exponentially. That is what we mean by expensive, guys. Okay, traditional architectures are expensive. What are these things? These are the problems that we are facing when we are facing the big data, guys. Okay, are you guys okay, guys? You with me? Can you give me a quick acknowledgement? Can I proceed here? Great. Thank you, guys. Move on to the next one. So there comes our solution, guys. What is the solution to the big data? By default, any company, the solution to the big data is Hadoop, guys. Okay, no company is ignoring Hadoop. If not today, tomorrow, everybody is touching big data, guys. So that's why Hadoop is becoming a default solution. Okay, what does Hadoop do? Hadoop is a software framework, guys. Okay, what does it do? Well, it will take care of all the internal complexities such as multi-node communication, threading, process, networking, replication, and all those things. So in other words, if you want to drive a car, you don't need to be a mechanical engineer. You just focus on turning the key. You turn the key, the car will drive. Okay, and you can also relate it to, if you're a cricketer, you should focus on batting and bowling. Okay, you should not go to the stadium, you should not clean the chains, you should not clean the stadium, or you should not clean the pitch, right? So what is happening in the traditional world, when people or when developers are encountering the big data, what is happening is they are focusing more on the framework level concepts and the operating level concepts rather than on business logic or the analytical logic. Okay, so what does Hadoop do? Hadoop takes care of all the framework level concepts and the operating system level concepts. It's an engine which will hide all these complexities from the developer and allow the developer to focus on business logic and the analytical logic, guys. Okay, that is why we're calling it as a framework. It supports data intensive distributed applications, guys, generally in a real world. Okay, what do? Well, you will end up having lots and lots of data. That is generally referred as a data intensive uh, application. The applications which work with so much of data are referred to as the data intensive applications, guys. Okay, and good thing it is free, guys. Okay, gentlemen, ladies, are you okay on that point, guys, on the first statement? Great, thank you, guys. Okay, it will also enable us to work with thousands of nodes and petabytes of data, guys. Okay, short and sweet. Let's say you write a program on a single laptop. You'll write a simple Big Hive or any of these scripts in Hadoop for a single laptop for maybe 1 GB of data for testing, guys. Okay, now you take the same code, deploy it on a 100 node cluster or 1000 node cluster. We will not make a single code change. Okay, in other words, your code is independent of the size of the data, guys. Okay, you can work with thousands of nodes and petabytes of data without even making a single code change, without even uh, making a single code change that you would generally do in traditional architectures, guys. Okay, does that make sense, guys? Do you understand that statement? Okay. Okay. All right, and it was inspired by Google, guys. Okay, so Google already was using MapReduce and the distributed file system concepts about 10 or 15 years back. Okay, what we are doing today is we are trying to learn these concepts today. If Google uses that, why do you think we should use it, guys? I'll give you a second. I'll give you a few seconds here to see if you will respond, guys. Okay, can you quickly type in your answers, guys? I'll give maybe about 10-15 seconds here to see what you would answer. Google is using it, okay, but why should we use it? Can you type in your answers, guys? If I were to ask you a question like that, what is your opinion? Okay, not many answers there, but here is the short and sweet answer, guys. Google